Okay, guys, if y'all will look at this right here, this is the sheet that I gave you that has all the colors on it. Now, what I have done is I've tried to print this out so you can actually see the emphasis that I'm trying to make on this. Now, the good news is this stuff it's not difficult. It's just very methodical. It's just like oxidation numbers. Once you saw it a few times, you're like, okay, I understand the rules. I understand what we're doing. Same exact process. Okay, it's just a little bit different set of rules that we're going to be going through. And so what we're going to be talking about is we're going to be talking about the empirical and molecular formulas. So just like we did whenever we talked about oxidation numbers, is I tried to get you guys to understand what it was before we ever did it. So this is defining it. So Brett, will you read me that first bullet right there that starts with "and"? Pause right there. That's the part that I need you to understand. It is the what? Say that one more time. Smallest whole number ratio. So, before I go any farther, let me ask you this. Have you ever seen a formula that looks like this? H2.1. Oh. Why is this wrong? Because it has to be a what? A whole number. That's problem number one. Okay, so let's come back to this. Finish up for me, please. Okay, so again, an empirical formula. What you need to know is it is a formula that has the smallest whole number mole ratio. So let me give you another example. So do you agree that this is a formula? That's the first question. Is it an empirical formula based on the definition you just read? How do you know? That's number one. Can it get any smaller than that? No, it cannot get any smaller than that. Why can't you reduce that any further? What's technically sitting right here? 1. You can't reduce that, right? Now, let me look at this. My first question to you is, just like the last time, is it a formula? Yes. What is the name of this thing? Anybody know? Did you just say H2O? It's hydrogen peroxide. Very good. This is hydrogen peroxide. So let me ask you a question again. Based on the definition you just learned, is that technically the empirical formula? Is it the smallest whole number ratio? No, because what can I do to those two twos? I can get rid of them, but the bad news is there's no such thing as those in chemistry. Okay? Now, let me ask you another one. First of all, what is that? Guys, you did this in biology all last year. It's glucose. Thank you, Romy. This is glucose. Based on definition, please stop. Is that an empirical formula? No. Why not? It's not simplified. It can be reduced. So we can reduce it to C what? H2O. That is the empirical formula. Now here's my question to you. Then how in the world do we have anything that has multiple sets of things? Like, how do we get from the CH2O to C6H12O6? Now, you just told me that by definition, now you'll see me write this a lot. This is the EF, which stands for what? The empirical formula. Can that get any smaller? Can you reduce that anymore? So if this is the empirical formula, what do you think this top thing is? This is the molecular formula. Look back at the very top of the page, Ryan. It says determining empirical and molecular formulas. Okay? So that is what is called a molecular formula. So it is the actual value. Now there is something that I want you to see. You've been doing this whether you realize you were doing it or not. And here's how you know. My first thing that I need you to understand is this can only be determined by an experiment in terms of the values. You can't just make this stuff up. It actually has to be calculated through an experiment. You'll see what I mean in just a minute. Now here's the part that you have been doing whether you realize it or not. Now if you have a pencil, I want you to circle this word. For an ionic compound, the formula is the empirical formula. For an ionic compound, the formula is the empirical formula. And again, what's the empirical formula mean? It's the simplest format. And let me show you how that you know that you've already done this. let's pretend that I had the formula Fe2S2. On the test, if you wrote that formula, would you have left it like that? No, what would you have done to this? You would have reduced it. You've already been doing this, you just didn't realize you were doing it. Okay? Now, why would we reduce it? Because the charges cancel and we can move on. So, this right here, if the question were, is that an empirical formula, would it be a yes or no? It'd be a no. But is that one? Yes. Let me give you one more just to make sure we're on the same page. What if you had PB, actually scratch that. What if we had Fe3PO4 3? Now, my first question to you is, and I should have asked this on the last one, is this ionic, yes or no? What things make up ionic bonds? Are these ions? Yes. So this is an ionic bond. Can this be reduced any further? What can you reduce? You can get rid of the 3's. So what you would be left with is FePO4. You've been doing this. Yes, ma'am. All right, say that one more time. I just want to make let's make it up. Even if it's not real, let's make it up. Go ahead. Fe8. Sorry. No, let's do it right. Let's just make whatever you want to make up. An 8 back here. No, because you remember, what do the parentheses do to the polyatomic? It protects it. So you can only, well, I did not mean to do that. It can only reduce what's there and there, not the 4. Okay, that's a good question. Now, here's the deal. Let's go back and look. For a molecular compound, is water a molecule? Is glucose a molecule? Sucrose, fructose, all those things are molecules. We're going to be working with those sorts of things. For a molecular compound, the empirical formula does not necessarily indicate the actual number of atoms present in each molecule. For example, now what does EF stand for again? The empirical formula of the gas diborane is BH3. Now my first question, can BH3 be reduced any further? No, that's the empirical. However, the actual, real, calculatable molecular formula is B2H6. But let me ask you something. Can I turn this into that? How? Reduce it, divide it by 2. So those are the differences. Now, just to kind of make sure we're on the same page, the molecular formula, again, is the actual formula of a molecular compound and a whole number ratio. So remember I told you up there, it has to be done experimentally. There are 3 ways they can give you the data. Number 1, they can just plain out give you the mass of each element of the compound. Number 2, they can give you the percent of each element in the compound, which is what you just did on the last test, right? You calculated mass percents. Or they can give you the total mass of the entire thing, and then the mass of one or more, if there are 2 or more, and then you need to calculate the missing thing. And let me give you an example of what I'm talking about. Let's pretend that I told you the entire mass of everyone in this entire room was a total of 900 pounds. Okay? And I gave you everyone's mass in this room but mine. How could you figure it out? Add up everybody's and subtract it from the total. Okay? You said divide. So, don't overcomplicate that. If they give you the total and they give you some missing pieces, or they give you some pieces and one's missing, just add it up and subtract from the total. Don't make that harder than it has to be. All right? So here's what I need you to do. I'm going to come off of this page and I'm going to go to this one. So you're going to need both of these kind of side by side. Okay? All right, so number 1. It says the quantitative analysis shows that a compound contains 32.38% sodium It contains 22.65% sulfur, and it contains 44.90% oxygen. And the question is, find the empirical formula. Okay? So, Lily, what I need you to do, and I'm going to come back over to this and just kind of show you, we're going to be right here where it says A if given a percentage. Okay, give me just 1 second. Let me go back. My first question is, let's look at all three of the points of data. What unit was given on all three of those? Percentages. Do you agree that's why we're starting where it says if given a percentage? All right, so that's what we're going to do. So, Lily, read that for me. That's where we're going to start. We're going to do that. So I am going to need your help because I'm actually going to come to this page. Actually, I already have it. So this is what I want you to do. I want you to write down what I write down. So we're going to write down 32.38. Now, it said drop the percent, change it to what? Change it to what? Grams. Drop the percent, change it to grams of sodium. 22.65. All right, drop the percent, change it to what again? Grams. And that's of sulfur. And then we have 44.90. Drop the percent, change it to what? Moles, right? I'm kidding. Grams. Okay? That's all we're doing. So that's the first step, very hard. No, you literally write a G instead of a percent sign. Okay? Now, I'm going to go back, and I'm going to make sure we're all on the same page. Now, read right here this big, bold, and purpley pink line for me, Lily. Right there. Oh my gosh, right there. Alright, so here's what I need you to do. Do y'all see where it says letter C down here if it says if given mass? That's where I want you to go. We're going to skip letter B. Now, it says if given mass, or you have changed the percent to mass. Haven't you already done that? All right, no. So what we're going to do now, Lauren, please read me that first little hollow bullet in green right there. Haven't you done that? You literally just did that on a test. But here's what the best news is. Is there one box with the Na in it? Yes, so you're not going to have to calculate any of the masses. You literally look it up and plug it in. Okay? So read that step one more time for me, Lauren. Very good. So we're going to go, if grams is on top, where does it go? Bottom. So we're going to go grams to moles. We're going to go grams to moles. And we're going to go grams to moles. Just like we've always had it before. If you've got a mole, what do you give it? A 1. If you see a gram, where does it come from? Periodic table. Sodium is 22.99. Sulfur is 32.06. And oxygen is always what? 16. Thank you. Now, would you need a calculator? Yes. I'm going to help you out on this one. Ooh, that's not what I want. So here's what I got. I got 1.4. Now, real quick, how many sig figs did we start with? Started with 4 of them. So we've got 1.408 moles of Na. We've got 0.7065 moles of S. And we've got 2.806 moles of O. So far, the only thing we've done, we wrote down the numbers that were given. We dropped the percent and changed it to a what? G. We changed it to grams. Then we converted grams to moles. We've done 2 things. And you've known how to do both of those things. Now let's go back and let's look at what we do next. Okay? Alan, please read me what it says right there in purple, please. This is super easy. Of the 3, which one was the smallest? Sulfur. All right. So just like we've done, we're going to take this number and we're going to divide it by the smallest. So 0.7065. Again, which number are we dividing it by? The smallest. Now, most of you are math wizards. Some of you are not. But what is any number divided by itself? 1. Wow, that was terribly difficult. So I'm going to go ahead and write a 1 right there. Now, the top one I am going to help you out with. 1 point, actually, let me do this. Equals divided by equals. And this is what I want you to write down. 1.99. And then I need that one divided by this one. It's nice when you have a graphing calculator to do all that work for you. I want you to write them down just like I wrote them, and there's a reason. Okay, so sodium is 1.99, sulfur turned to 1, and then oxygen turned to 3.97. And this rule right here is the most important rule in everything that we're fixing to do. So if I were you, I would put a little star beside it. But let me help you out first before we get there. Because of rounding or experimental error, a compound's mole ratio sometimes consists of numbers close to whole numbers. Do you agree that we had two values that were not exact? Didn't we round a bunch? If you punch all those numbers in, I promise you there's a bunch of rounding that went on. So what I want you to do is right here where it's green and purple, put a huge star beside that. This is the most important rule in everything we're fixing to do. Okay? In this case, we have the 1-9 rule. What is this, you ask? What is the 1-9 rule? Sharon, will you please read me that in pink? Hold on. Which number? I'm fixing to make this really difficult. Which number? Say it again. Just read it. Hang on. Which one? Which number again? The first number. All right, keep going. Hang on. To what side? Ryan Dismukes, you seriously got to stop, dude. You're going to mess somebody up. The first number to the right of the decimal has to be a what? A 1 or a 9. Super dumb, but super easy. For it to round to the whole number where? To the left. This is called the 1-9 rule. So if I go back and I look, are both of my numbers to which side of the decimal? The right, a 1 or a 9. Yes. So will they round? Yes, they will. So this turns into a 2. This stays a 1. And this turns into a 4. Exactly. And if we come into one of those, I will tell you what to do. We haven't got there yet. If it's a 7, it will not round. So all of your old rounding rules, 5 and above round, do not work with this stuff. For most of it, it'll work. But I promise you we have an easy system that's going to make it easier. And this last step is the final thing because, again, what are we trying to determine? Empirical what? Formula. Are those numbers formulas? No, they're not. Read the very last step right here. Once every element has every element satisfied the 1-9 rule. Bailey, read that right there in red. As what? Subscripts. These to the elements they apply to. That is your empirical formula. So your final answer, once we come back to this, would be what? What are these numbers going to be plugged in as? Subscripts. So your final answer is, let me write it up here, Na what? 2, S, you don't have to write the 1, O, and that is your final answer. You tell me. What did we just solve for, Massimo? The empirical formula. Very good. It is already reduced. Okay. Now, why couldn't you reduce that anyways? There's already a 1. Sulfur's already a 1. That is so like if I ask what is the empirical formula, that is your answer. Yes, ma'am. Because what are we solving for? The empirical what? That's the formula. All this other stuff is math. Okay? No, we're good. We got one more. We got one more in us. Okay? All right, if that's the case, some of you are fixing to get super mad, but that's okay. I can't help it. Scroll down to number 3. Scroll down to number 3. Let's do number 3. So we're going to do this. We're going to do this one a little faster. Now, what units are all those things given? The compound is made up of 26.56% potassium, blah blah blah, chromium, and oxygen. Oh, this is a good one. Now, my first question is: underline this word in that question, and the remainder. Underline remainder is oxygen. So, how do you find how much oxygen was present? But they don't give you the total. Why is it 100? I'm making sure you know that. You would be shocked at how many people said, I don't know what the total is. All percentages should add to what? 100%. Somebody actually, if you have an easy calculator, you can do that. I do need that. I do need your help on that. So 26.56, 35.41. What is it? Thank you, sir. 38.03. Now, all those are in percents. What do we do to percents? Drop it and change it to grams. So I've got grams of potassium, I've got grams of chromium, and I've got grams of oxygen. Now, you should already know. Next step. What do? By what? Nope. I've convert grams to moles. Convert grams to moles, and convert grams to moles. Now, mole. The molar mass of potassium is 39.10. The mole of chromium is 52 even, and the mole of oxygen is 16 even. So let me run your numbers for you real quick, and I'm trying to get to a certain point. 26.5. Don't. Sorry, I should not have thrown my calculator. When I needed it, it shut off, and it takes it a minute and a half to come back on. If you have a calculator, some help, like... Work, hurry. Oh, that's that stupid song. All right, so this is what we got. Write these numbers down, please. These are all of our number of moles. Okay. Now, this is actually good. This is actually a good question, guys. Y'all stay with me real quick. Now, do you agree that there are two numbers that are very, very, very close? Yes. When you divide one of those by the smallest, aren't both of them essentially going to become one? Yeah. But pick the smallest one, which is which one? The top one. So 0.6792. Now, obviously, that's going to become a 1. That's going to become a 1. Now, watch what happens here. That divided by the top one. Watch what happens. This is what I get. Dun, dun, dun. What rule does this break? The 1-9 rule. So let's go back real quick and let's see what we do. And again, I normally do a lot of problems before I show you one of these, but somebody asked to do it. So here's what we do. So what if one or more of the numbers do not have a 1 or 9 to the right of the decimal? This is what you do. Multiply what? Say first word again. Every element by what? 2. And recheck. Now, you guys, I hope, are smart enough. What is 1 times 2? 2. So I'm going to say times 2, times 2, times 2, and this is 2. This is 2. What is 3 essentially and a half times 2? 7. Now, does every number satisfy the 1-9 rule? What do you plug those numbers in as? Subscript. So your final answer is K2CR2. 0207. What is the name of that thing? Again, it always comes back to a polyatomic. Dichromate, potassium dichromate. Give me 2 more seconds. Give me 2 more seconds. I want to make sure that we all, because I did it really fast. Here's the problem. Why is that wrong? Listen, stay with me, please, please, please. The first number to the right of the decimal has to be a 1 or a 9. Now, when it's not, what do you multiply by 2? Everything. Every year, I predict what people do. People forget to multiply those numbers by 2. So they write K1CR107. You've got to do all of them, not just the one that's not a 1 or a 9, okay? Yes, sir. Gage. How'd I get what? Because if you divide that number by itself as 1, and isn't that really, really, really close? It's 1.